Thank you all participants, those who are patiently waiting for starting this webinar. We are starting the webinar now. I request all panelists and the discussants to have their videos on, and we can start the program as per schedule, please. Over to you, Mr. Satyanarayana.
Today is our second pre-conclave lecture organized as part of LTC 2021. I welcome all the audience. I understand about 1,000 plus people have registered and people are taking in, participants are taking in from all over. So first, let me welcome our audience. And this is a bit of an odd time which we are experimenting as we wanted to make it global. And our speaker for today is Professor Prasenjit Mitra, who is the Associate Dean of Research at the College of Information Sciences in Penn State University. He is teaching in the College of Information Sciences and Technology at Penn State University, and he is also the Associate Dean of Research. Welcome to you, Professor Mitra. We are very privileged and happy to have you today here. And it's an odd time for you also, very early morning, and a bit of an odd time, dinner time for us. I hope it is not a punishing schedule for you. I welcome you. Friends, we have with us today Dr. Sachidanand, the Vice Chancellor of Rajiv Gandhi University of Health Sciences. The Rajiv Gandhi University of Health Sciences is our partner organization. I welcome you, Dr. Sachidanand. He is an excellent teacher and a distinguished dermatologist and an accomplished healthcare administrator. Friends, I would like to welcome discussants. We have in our webinar model a selected group of distinguished guests coming from the domain area who will be interacting closely with the speaker of the day, and we call them discussants, somewhat similar to panelists. We have 7 discussants today. I welcome to all of them. I would also like to welcome our core team members of the conclave who are helping in organizing the whole activity. I also welcome our program chair, Professor Shalini Aras. Most importantly, I would like to welcome Dr. Saibaba, who is chairing the session today and conducting the program. Professor Saibaba is also a member of our core team. He is the TV Raman Pai Chair Professor at the NIAS, National Institute of Advanced Studies. NIAS is also our partner organization. I forgot to mention our another partner organization, Dr. Mudkavi, who is the director of CSIR 4 Paradigm Institute, is also here. Welcome, Dr. Mudkavi. CSIR 4 Paradigm Institute is the 4th organizational partner. Dr. Saibaba, as I said, is currently the TV Raman Pai Chair Professor. It is a chair instituted by Mr. Mohandas Pai, the former Infosys famous, who was the chief of finance there. And NIAS, all of you know, and Professor Saibaba is previously he was the director of resources management group at IGCAR. He is a well-known nuclear scientist. He is an outstanding scientist, and his connect with the information world is he was the director of resources management group at IGCAR, that is Indira Gandhi Center for Atomic Research, for several years. And as part of this resource management group, he was also heading for several years IGCAR's library and information system also. Professor Saibaba is a senior professor of Homi Bhabha National Institute also. Currently, his working domains are the science and risk communication, human reliability program, understanding ancient Indian knowledge system for applying them for the holistic development of youth, which he is engaged with at the NIAS. And Professor Saibaba made very significant contributions for the implementation of several high-impact activities of relevance to IGCAR and DAE, that is Department of Atomic Energy. He has displayed commendable leadership in providing access to scientific information resources, particularly catering to the varied needs of researchers and a large community of students. He was also heading the Scientific Information Resource Division, as I said earlier, and he contributed in diverse domains, which included human resources development, financial management, workflow automation to aid to move towards a paperless office, technology transfer, and IP rights while at IGCAR. He has also carried out postdoctoral work at Texas A&M University, USA, and at the research center in Zurich, Germany. He has several publications to his credit, and he is a thorough researcher. And he was conferred with the Doctor of Science by MGR University Education and Research Institute. He is a member of several high-level committees and constituted by DST and UGC. I welcome you, Professor Saibaba, to chair this.
Thank you, Sachak, for very generously introducing me. Yeah.
A few words about the conclave. As all of you know, Informatics started its library technology conclave about 5 years ago. This is the 5th in the series we started. We should have organized in May, but for COVID, the situation, we had to put it off. Earlier, we had planned to organize in NIAS auditorium. Now it is a webinar series. As a webinar, we decided to have it in as a series of webinar program in sequences. This second in series has started today. The conference lecture was delivered by Professor Samir Brahmachari, former Director General of CSIR, on 6th of this month. Today's lecture is being delivered, as I said already, by Professor Prasenjit Mitra. We have on 11th of next month, the 3rd lecture in this series, which will be the 17th annual lecture on informatics. Our annual lecture on informatics, which was instituted several years ago, is now organized as part of our LTC. So this lecture will be on December 11. Please mark your calendar. This lecture will be very interesting for all of you. This will be on data science, the good, the bad, and the ugly, which will be delivered by Professor Jain Tharitsa from Indian Institute of Science, who is a famous computer scientist and data scientist. Followed by this, on January 7th and 8th, we have 2 workshops, pre-conclave workshop, one on AI for e-science, another on ontology for data management. After this, from 27th to 30th January, we are going to have the conclave, which will have 6 thematic sessions of 2 hours each, 2 sessions each day. And the details will be announced very soon on our website. I request all of you to visit our website. It's simple to easy to remember, LTC2021.org. And we are going to have, as part of this, an innovation award where case studies in innovation will be presented by organizations in the area of digital library domain. That will be an interesting thing for you to watch. So once again, I welcome you all for this LTC 2021 series of programs and today's program. Friends, I must talk to you a little bit about informatics. Informatics was started 40 years ago. If I start talking about informatics, I will take the whole time. So instead of spending a lot of time talking about informatics, I would like to make a 3 minutes, less than 3 minutes presentation on informatics, which will be a multimedia presentation. I request Mr. Sanjay Grover, our CEO, to present this multimedia on informatics. Sanjay, over to you.
Thank you, Satya. Devendra, I have rights.
Yes, yes, you have.
Okay, so here is a small multimedia on informatics.
40 years ago, when information was scarce and online was unheard of, informatics was envisioned with a digital vision by an entrepreneur working as a librarian then to bridge the global information access gap in the country. This pioneering vision is a global company today with products and services benefiting millions of users in the academic, research, and corporate segments around the world. India Today magazine described the venture as the first online information company in India for global knowledge access. Serving global information companies on a project for supplying consolidated Indian business information helped Informatics to ideate its first digital information product named India Business Insight, IBI. Credited with the enviable reputation as the pioneers in the online and CD-ROM-based information business in India, Informatics started creating new digital information products through 1990s. Neuromed on CD, a product initiative funded by NIMHANS Bangalore, was the earliest e-journal archive in India for Indian medical journals. Driven by the internet advantage, Informatics developed its first global information product named JGate. JGate is truly the world's largest database for journal literature by its coverage of over 50,000 journals. The journey has continued with a diverse portfolio of products and services evolving across 4 business units: information products, digital library solutions, enterprise content management and publishing. The product family of Informatics is a growing list with innovation driven by the latest in technology and evolving market needs. In an industry where content is the king and technology is the master, Informatics has been a proud pioneer and leading player. Gaining 40 years of insightful experience by 2020, Informatics continues to be driven by values with a passion to deliver excellence.
Thank you. That was a small introduction on informatics.
Yeah.
Over to you, Satya. Sir, you are on mute. Satya, sir, please unmute yourself.
Friends, you just heard about Informatics, which is a 40-year-old company. We especially take pride in calling ourselves a pre-internet online company. Most of the current day generation does not know that there was an online long before internet came into picture, and we were part of that history, and we continue today in the online business. Thank you very much for joining. Now I request Professor Saibaba to take over and conduct the meeting. Thank you, sir.
Yeah, thank you, Satya, for having the privilege of me associating with this conclave, and also in particular chairing today's session. Well, I think Satya already mentioned this is a Library Technology Conclave 2021. What should have been 2020 is shifted 2021, living because of the COVID. And today we have two people speaking. One is Dr. Sachidanand. It will start with Dr. Sachidanand, and it will be followed by the Professor Prasenjit Mitra. So I have the privilege of introducing Dr. Sachidanand. He is the currently Vice Chancellor of the Rajiv Gandhi University of Health Sciences at Bangalore. He is a man of many firsts, very excellent academic record, multi-talented personality with a distinguished career record as a teacher, researcher, medical practitioner, and more importantly, administrator. I understand he's playing a very important role in looking after the COVID, how do we handle COVID issue in Bangalore and Karnataka. So prior to taking over the Vice Chancellor at the Rajiv Gandhi University of Health Sciences, he was the Dean and Director at the Bangalore Medical College and Research Institute. And he was also served as the Registrar at the same university, Rajiv Gandhi University, and two times during 2007 and 10 and 14 and 16. And his educational career has been excellent. He's a gold medalist in anatomy and many firsts to his credit. He stood first in his specialization in PG diploma and first rank in MD, first Indian doctor to be successfully audited by Foods and Drugs Administration of USA, first to start hair transplantation in Victoria Hospital. I can go on many firsts, the man of many firsts. I think he was also served as the president of Indian Association of Dermatologists and venerologists and dermatologists from Karnataka. He has several publications. He's authored and edited books. He's the chief editor of the 4th and 5th edition of the IADVL textbook of dermatologist. I can keep on telling about his credentials. We're very happy to have him here as a part of this conclave. As Satya mentioned, is one of the co-hosting institute. So very happy to have you, Dr. Sachidanand, and I now invite you to deliver your talk.
Thank you, Dr. Saibaba, for that generous introduction.
Yes, thank you.
Humbled by your generous introduction. I'm extremely happy to be a part of this Library Technology Conclave 2021, and also being a partner of organization, one among the four, that is Informatics, then Rajiv Gandhi University of Health Sciences, National Institute of Advanced Sciences, and CSIR, the fourth paradigm. It's very pleasant day for that, pleasant evening rather. We have been, there is a famous saying, whenever Chennai sneezes, Bangalore coughs. We have been very affected by the Chennai cyclone, and presently the temperature in Bangalore is very, very pleasant, very cool, and we see a lot of clouds. When I talk of clouds, it reminds me of cloud computing and things like that. And I belong to an era of physical libraries and traditional libraries and things like that. Now today, it's very heartening to note that library sciences has grown to such an extent. The science, e-science, and also the technology, on the other hand, have expanded to such vast, infinite proportions. And this marriage of convenience between e-science and technology is what we see as digital sciences today, digital libraries and digital sciences. And it's such a exciting field. And what used to be traditionally a very limitations for storing information through books, physical books and physical journals, today there is no end to that. It's become a vast and infinite thing. So with the digital libraries, we have conquered the space, one. Number two, we have also conquered the time. We have also conquered many such advantages by shifting over from physical libraries to digital libraries. And that is what is the advantage. So we are at a time when we have seen both the worlds, best of both the worlds. And I was just mentioning about clouds. So instead of cloud computing, because of the vastness, because of the infinity attached to this, I think we can start calling it as sky computing, move on from cloud to sky, and that is what is the which says that it is infinite sciences we are looking at. So today I am very happy to be a part of this program, a pre-conclave lecture being organized as a curtain raiser for the conclave that is going to be held in January 27th to 30th. So my profound thanks to Sri Satyanarayana of Informatics for inviting me here. We have been working together for quite some time now, and we are partnering in many projects as well. And all my students of the Health Sciences University are using JGate, their search engine, and they're very happy about it. And in fact, they gave us a lot of support during COVID when the colleges were closed. And that's the time when many students used the e-textbooks, e-journals, and all those modalities of internet usage, so that it benefited a lot. The students actually went home very suddenly and did not carry their books, and that is where JGate came as a great advantage to us. So my salutations to Dr. Prasenjit Mitra, who is the star speaker for today's program, who is Associate Dean from Penn State University, Philadelphia, USA. And my salutations to Madam Professor Shalini Aras, who is the Conclave Program Chair, and all the other discussants who are very eagerly waiting for to discuss with the speaker. Without much ado, I would like not to hold you all with the exciting lecture that's expected from Prasenjit Mitra. Thank you so much for inviting me. I'm very, very happy to be a part of this. And of course, as a health science man, the health informatics is such a big thing now. We are now looking at establishing a Center for Health Informatics under Rajiv Gandhi University of Health Sciences, which is going to be one of first of its kind in the entire country. We're looking at that thing. Thank you so much. With these words, I would like to hand over the mic back to Dr. Saibaba. Thank you very much.
Thank you, Dr. Sachidanand. They said brevity is a reflection of wisdom. Thank you very much. I think also moving from cloud to sky. Thank you. Well, I think that is the way things are going to go. Now I have the privilege of introducing Dr. Prasenjit Mitra. Well, I think it's early morning for him, I guess, that good morning. And in the era of webinars, we need to start by saying good morning, good afternoon, good evening, and because people are coming from different domains. So I think Dr. Prasenjit Mitra he did his BTech at IIT Kharagpur, then went on to do his master's in computer science at the University of Texas at Austin. Prasenjit, I was at Texas A&M University. You know how this Austin and College Station compete. Then he went on to do his PhD in electrical engineering at Stanford. Currently he's the Associate Dean for Research and College of Information Science and Technology at the Penn State University, USA. I think he has a very distinguished career. His current research interests are in the areas of big data analytics, applied machine learning, and visual analytics. And in the past, he has contributed to the areas of data interpretation, data cleaning, and digital libraries, especially in tabular data extraction and citation recommendation. I think while doing his PhD, he investigated issues related to modeling data and the semantics of data in an information integration system. It is way back in 2004. Now you know how relevant it is in the current era. While at Penn State University, he has pursued research in a broad range of topics ranging from AI, machine learning to data mining on the web and social media, scalable data cleaning, political text mining, chemical formula and name extraction from documents, and the extraction of data and metadata from figures and tables in digital documents. He has executed several projects from the DOES project funded by the NSF, and he also got the NSF Career Award. And his research has been supported by the NSF, Microsoft, DoD, DHS, DOE. Looks like he has a knack of getting funding from several agencies in USA. I think he moved from academics to industry to academics, and right now he's heading at the university. And his work along with his co-authors has resulted in visual analytics system that was awarded the IEEE VAST 08 Grand Challenge Award in the data integration area. Well, I can keep on reading about his excellence, which is achieved, but I think we would like to listen from him. So I would stop here, and I would welcome Prasenjit to deliver his lecture. He's going to talk on digital libraries and research data management. Well, Prasenjit, the audience are for you. About 45 minutes is the time. Maybe 5 minutes before I try to somehow reach you and wave my hand if it is at 40 minutes. So may I now invite Dr. Prasenjit Mitra to deliver his lecture.
Thank you, Dr. Saibaba, for the very kind introduction, Dr. Shalini Aras, and Dr. Sachidananda, Dr. Satyanarayanan, and everyone who has worked so hard to make this possible. So it's a great pleasure to be speaking at this pre-conclave meeting, and I am very enthusiastic that there are so many people logging in and listening to this live on Facebook. So without further ado, I will let me share my screen and go to the talk. So today I will be speaking about digital libraries and research data management. And so what is research data management? So essentially, research data is data that is generated from all the research that goes on in our scientific endeavors all across the world. One of these examples, and by no means am I saying that this is the example, but I chose one example. So this comes from Springer Nature Research Data Management Service, and they say that these are the benefits. So Springer Nature can host your data. So any research generates some data, and we'll talk a little bit about the heterogeneity of the data. These are of many different types. And by hosting it here, they offer expert curation, and you can save time, increase exposure by having the entire community look at this data, and meet the data sharing requirements that the publisher, institution, and funder places on you. And that's happening more and more in today's world, where if we get funding, we are said, okay, we have to publish the data and make it openly available to everyone, which is, I think, a very good thing. So this is what I mean by research data, and this is one of the services that are available. So now, to look at the heterogeneity of the research data, this figure, again from Springer Nature, they show you all the different types of data that these repositories need to handle. So they are from audio to video to documents, graphics, molecular data. This is of a particular type that arises from biochemistry experiments, geographical data, Esri, and so GIS data that comes in, PowerPoints, code, and Python notebooks, and so on and so forth. And of course, I would be remiss if I didn't mention Excel and zip files. So this is all sorts of different types of data that needs to be handled and stored. And you can bet that in the future, there'll be more and more different types of data. So why do we want the research data to be hosted in a digital library and shared, or in general in a research data repository? So the idea is, I think, there are a lot of benefits by putting the data out. Even when I do some research and I publish the findings of my research, I have my own biases. So I'm looking at the data and I'm drawing some conclusions and I'm putting the conclusions out. And we are doing this over project after project after project, hundreds of thousands of projects all over the world. Now, on each data, you're getting only one or a small set of brains working on it to interpret the data, to interpret the data and come up with the results. Now, if we can share the data, then we can crowdsource it publicly to anyone who has expertise, can look at the data and comment on it and come up with maybe things that I have not looked at. There are people are looking at things like we do some experiments and we say, okay, this is statistically significant and this is not statistically significant. And last year or so, there were 800 statisticians who signed a letter saying that, well, 50% of the experiments and the conclusions that have been done where they claim statistical significance or the conclusions that they're drawing are not really statistically significant. Or what does it mean to be using the t-test usually? And you say, okay, the null hypothesis is validated or invalidated, and people are drawing conclusions that should not be drawn. So now if we have the data, then someone can go in and look at it and say, no, maybe it is statistically significant, but it's very weak, or it is not statistically significant, or just because this is the data, you cannot make these conclusions that you're making in the paper. Now, once people make those conclusions in the paper, we verify things, but the reviewers are not going back to the data and looking at exactly what the data is. So the reviewers are taking the authors on face value. Now, by publishing the data, we can allow people to do their analysis and come up with better conclusions. The data can also be used for completely something else. The multiple data sets can be linked together to draw conclusions that we cannot draw from a single data set. And so those are some of the benefits. Now, of course, when we have something, it has to be of benefit to the individual researcher as well as to society and science and research. And of course, I have talked about how publishing research data can help drive sort of societal benefits, that scientific innovation will be improved by publishing the data openly. However, there has to be some incentive to whoever is publishing the data to be getting credit for creating that data. And I would say, unfortunately, the amount of credit that we give for journal articles, we do not give similar credit for publishing very good data. And that needs to change in the future if we want people to publish more and more of their data, because it does take time to generate good data, to create the metadata and to publish it. Now, metadata, for the most people in this audience knows what metadata is. It's basically data about data. So data that is describing your data. What does this column mean in a table? So metadata is used to exactly specify the semantics of the data columns. Now, what we have seen, as Dr. Saibaba mentioned, my research thesis about 20 years ago, I was working on how we can capture metadata so that a lot of the data can be searched more easily, can be found more easily, can be linked better. Okay. 20 years later, we are still working on that problem. We have made some progress. But the problem is that generating metadata requires some amount of work and effort from the research community. And the only way we can get that done is if we give proper incentives. And unfortunately, that incentive structure is not there. So you would say that, well, generating metadata takes time. Well, so does writing a paper. So we do write papers, but people, on the metadata side, people have generated metadata very sloppily. Some metadata is missing. Why? Because to the researcher, there is not much benefit given by society to publish good quality data. And I think that's one of the areas where I would think that we as a community need to generate consensus and provide incentives to our junior researchers, especially, as well as senior researchers, to get credit for publishing good quality data. All right. Now, once we say, okay, people are willing to put in the data, and we have some of the metadata, then comes the issues that are there in the back end. So the issues that are there in the back end are essentially, we have to manage the digital data. You have to handle the formats right. You have to do quality control for integrity. So that means that we have to make sure that the data that we have is accurate, and there's not, people are not publishing fake data or garbage data and things like that. We have to store and provide security, as well as enable collaboration. Now, of course, people who research in security know this. The most secure way of securing something is, if I have, I have some piece of paper and I want to secure it, the most secure way of securing it is to put it in a lockbox, put a lock and key, and maybe drop that box in the Mariana Trench in the Pacific Ocean. Then nobody will ever get to it. And it's hugely costly to get it outside, out from the ocean. So that's secure forever. But that's not what we want. We want collaboration. So we want to balance collaboration. That is, we want the data to be out, people to use it, people, to collaborate, yet to be secure so that nobody can mess with the data and change it, and we can ensure that it is not hacked, let's say. Preservation and archiving, there is work going on, and I possibly won't have the time to touch upon that, but that's very important, especially in the digital realm of things. So, for example, we have had paper for what, or this version of paper, I'm not talking about the Chinese papyrus, but this version of paper and the printing press and so on for 500 years or so, let's say. So we know, okay, paper, we print, paper is, the books are there, we can pick up a book and read it. But with digital technology, there have been changes in the formats and so on, because that technology is still evolving, and it's evolving so fast that if somebody has something in a floppy disk from the 1990s, right now you wouldn't be able to read it because we don't have the machines or the software and so on and so forth. And because of the changes in technology and the formats and the standards and the metadata standards things, there is an issue with respect to archiving and preservation. And that's separate from the issue of backing up for redundancy, because in backing up, what you're making sure is that you have multiple copies of the data, and if God forbid I have it in my house and there is a flood or a hurricane and the data is destroyed, maybe I have a copy also in Australia and in India, so that those copies can then be used. So that's the redundancy part. Now this one shows you, it's about 10 years old, but this shows you some of the formats that the UK-based research data sharing consortium, the research data service, they said these are the formats that we should put in the data, so if we want it to be accessible in the future, and it's the best for archiving and so on. So as you see, the simple formats like text and PDF, which has pretty much become a standard. There is open data text formats, and you can see markup using markup languages such as XML to put in some of the metadata, and keeping it sort of simple in text and RTF is the best, at least with respect to text. Similarly, with video data, they are suggesting MP4 and JP2 and so on and so forth. So we need to keep in mind about the long-term archiving issues. And if we want to have people share the data, as I have alluded to it, we need metadata standards. Now, this is some of the metadata standards that are there. Dublin Core, DDI, Data Documentation Initiative. There are some specific, domain-specific metadata standards, for example, for geospatial data, for genomics data, and so on and so forth. And this is just a sample. Again, why do we need so many standards? Well, because we can't have one single standard, because biological data is different from astronomical data, is different from geospatial data. And we, whenever we design these standards, it has to be nimble enough so that we can describe our data well. And if you're using the same standard, it'll be really big and unwieldy and so on. So we will have multiple standards, and we will have to, what we call interoperate using these multiple standards. And these standards will evolve. What we need to make sure is that they are backward compatible so that at least the data that we want to preserve and archive is easy to take forward. Or we build some tools that can convert these within reasonable costs. A recent, not so recent, let's say in the last 5 to 10 years, all of these ideas that we are talking about, research data sharing, has been collected and into a set of principles. So any science, when you sort of need some theory, some organizing set of principles. What really are we doing? We talk about data, we talk about metadata. So this is a nice name called FAIR that they have given. So there are these FAIR principles that people have designed that I think is a good first step in reusing the data after finding the data. So if you want to reuse, we all publish data all around the world. What we need to do is to be able to get the data from some researcher in China who I have not heard about. I didn't even know that they did those things. When I go to publish my research data, or even maybe before when I start my research, I want to see what data is there. I can do some searches and find things. Right? So FAIR is an acronym actually. F is for findable. So findable means we need to find the data, pretty simple. And the way to do that is through metadata. So metadata describes what the different pieces of the data are. If I give you a bunch of zeros and ones, you won't know what it means. So you need to have the metadata to describe, okay, the first 6 characters mean this, and the next 20 characters mean that, at least. So that's what the metadata does. And it has to be sort of rich metadata. I copied it, so R1 below, basically, if you want to see it, you can. The R1 is, R is for FAIR. So in the next 2 or 3 more slides, I'll define that R1, so if you're wondering what that is, but let's forget about that for now. So it has to be rich metadata, clearly written, and the concept of identifiers is very important in research data management. So, if we have duplication, if we have replicas, because we don't want one data set to be lost, and if we want to find something related to some particular entity, if we have identifiers, now we can take data from multiple sources and put it together. So, if you have data about me in the US census, and if you have data about me in some census or some other, ration database or something in India before I left India, if you can connect those two, then you can get the whole story of my life that, okay, I was in India for this amount of time, I did these things, I went to this college, and then I was in the US. So identifiers are very important if you want to enable data integration. And oftentimes, okay, we might not have the same identifier. My ID in my college in IIT Kharagpur is not connected to my social security number in the US or something. So if we can tie those together, then we can bring data from the same entities together. So that's why it's quite important. And we are hopefully making some progress towards getting there. And then the metadata needs to be registered and indexed in a searchable resource so that we know where to go and search for things and find things. Okay, so A is for accessible. So we need to be able to find this data and the metadata, either using the identifiers or using some search tools. And it has to be, the protocols have to be free and open and universally implementable. So, you know, everyone has to get onto the system. If we have a protocol that is closed, that only one provider knows how to manage and link and do things with, then of course some other provider will have their own different protocol, and then we will have sort of a Tower of Babel, as in all these different protocols are different, nobody speaks to each other, data cannot be linked. So that is why we need open free protocols. And yet we need authentication and authorization. So we need to make sure that this data is not fake. We need to make sure that this data has not been tampered with, and so on and so forth. Okay. Interoperable. So the difference between interoperability and integration is that integration brings everything together to one place. Think about data warehouses. You collect data from multiple places, you put it in one place, you connect them together. That's integration. In interoperability, the vision is that the data resides in these individual databases, and we somehow, you know, there's possibly a coordinator, and you can access things through the coordinator, and it would go to the individual databases and bring data together and connect them nicely so that you can answer your queries. So interoperability enables connection of data from multiple data sources without the data moving, the entire data moving per se. You know, only the snippets that are needed to generate the answer, perhaps to your questions or your tasks, are the only ones that are moving. And in order to do that, one of the important issues is the issue of vocabulary. So whatever I am calling something, you know, if you call something a truck and someone else calls it a lorry, we need to be able to connect that, oh, truck and lorry are roughly the same thing, and enable those connections across these databases to make sure that we can connect the data across these databases. And so that's what we need. And that's why we have these things called ontologies, where essentially you're describing the data and you're describing the concepts that are in the database, and then using that to connect similar things. The fourth one is reusability. So what we want to do is, of course, we don't want to create the same data again and again. And if we are putting the effort to store the data, then essentially the data needs to be reusable. So what that means is that, you know, we create the data once, and then we can use the same data in a different application. And so we can, we don't need to reuse the data. We can say that, well, we can share the data more easily. All right. So this is the this is one of the main points that I want to make, is that as a community, we have to come up with better incentives. Right now, I don't know if we put as much incentives to publishing and sharing data to different, you know, to our scientific community. So this is from a paper. This, I think the source is the paper. And you can go and look at the paper. And they did a survey. So they did actually a systematic review. So they went in and looked at all the work that is there. And this is only, of course, they did it only in the health and medical domains, but that's a very big domain, very important domain. And in a domain in which perhaps we need the data to be shared in order for all of us to, you know, if you want to know whether hydrochloroquine helps with COVID-19, we want to see the data, and we want to see the biases in the data. and we want to understand, this paper perhaps is shaky, even though it is claiming that it works, its data has been collected in this way. And it has these biases, so that's why it's making it look much better than others. Anyway, so the point there is that they looked at this health and medicine data. And they said that the only thing that they found is there's this open data badge, which was a tested incentive that motivated researchers to share the data. And this was primarily reported in this paper that I have quoted. And other than that, the open data badge are some form of collecting a number of badges, and the number of badges are you can have gold, silver, platinum, whatever different badges. Based on that, you can sort of reward junior researchers and senior researchers. I say junior researchers because primarily junior researchers are evaluated more strictly to see, whether they will get tenure or permanent positions and promotions and so on. So for all of these, this is the only known tested incentive. And this is a quote. I usually don't quote full sentences, but this deserves sort of quoting. It says, the literature is full of opinion pieces that emphasize the lack of incentives for researchers to share data, outweighing the number of strategies that aim to increase data sharing rates in health and medicine. And observational studies that identify data sharing patterns and barriers are also plentiful. And whilst these studies can provide useful background knowledge, they do not provide a good evidence of what can be done to increase data sharing. So essentially everybody has ideas, and then everybody has anecdotal evidence, but we need to do more systematic studies. So if anyone out there is looking for a problem to work on, this is, I think, one of the important problems that we should be looking at and trying to figure out what incentives work. Because it's not, there might be technology problems that we can work on. We have been working on for a while. But there might be policy issues. We will work on all of these, but primarily I think we need to get the incentives right. All right, so that's sort of a general view of what I think are the important issues in research data management today. And I'll close with a paper that came out in May called Trust. But in between, I want to show you a little bit of what we have done and show you some of the things that we have had to deal with and design some solutions. So one of the systems, so I have worked since 2003 when I came to Penn State. I have worked on essentially at that point, it started as the Sightseer system. And then Sightseer became Sightseer X, which is the next generation version of Sightseer. And we generalized it to Seer Suite. So essentially, we reconstructed the software so that it can be used in other domains. Sightseer was initially and primarily designed for computer and information science papers. So roughly, those of you who have not used it, it goes out and grabs papers from the web, indexes them, makes it searchable, and a whole bunch of other things that I'll talk about. So we had some archaeologists who came to us and say, hey, you have this Sightseer system, that is great. We want to search for papers in archaeology, but we said, okay, we'll use the Sightseer system and put it up. But then they said, well, but we also need you to be able to search. This is what we want to do, search for old maps. So we need a quick way to search for old maps, which are, by the way, different from current maps, because right now there is no such country called Prussia. And in some older maps, you would have that. And they want to find out what is the boundaries and so on and so forth. So what we had to do is we had to not only index the text, but we had to extract maps from them. And then we had to extract information in those maps and information in the captions and in the text about those maps. So here I'm using data in a broader sense, in the sense that it's not just text, sorry, it's not just numerical data, but it is text, it's maps, it's place names in the maps, names of rivers and bridges and all other things that we tried to extract from maps and then index them and make it searchable. So this was one of the projects that we did. The biggest, we spent about 5 years working on this project called ChemX here. And then 2 more years. So the 5-year project was funded by the National Science Foundation. It was a basic science project. And then after that, we had 2 more years where we were working with Dow Chemicals, the chemical company, who wanted to use this for an internal search engine in their company. So that was very, that was nice in the sense that a real chemical company using your research projects is at least some sign of impact. So what is this? So essentially, we built a linked data repository and digital library. And a digital library is where you have papers, and a data repository is where you have the scientific data. And I think it's important to link those two, and not only link those two, they should just, when we create in the future, it should just go hand in hand, because we have the data from the research and then we have the related publications. And if you want to know more about the data, you can go into the digital library, just following a link, and read about the data more so that you know what the data means. You can have metadata which will describe the data, but even then you cannot have the entire, let's suppose the experimental conditions are like 1 whole page in a paper. I possibly can include that in metadata as text, but most people don't. So you put some brief description of the metadata as to what the data means. But if you have the link to the paper, you can go in and you can find out as much information as you want. And in this case, the reason we linked it is because our scientists came to us and said that they need some of these things to be implemented automatically, because they are interested in data that now only exist in these papers. So the papers were published in 1970 and so on, some of them. And they had information about the amount of water in soil in a certain place at that time. So we were working with environmental chemists who were interested in kinetics and so on. But they wanted that data, so they were employing a postdoctoral scholar to go into these papers and extract the data manually. And then they put that data into an Excel sheet and then move it to a database and query and so on and so forth. And the standard search that we had also didn't work because at that point, at least, the search engines did not understand the semantics of chemicals, chemical names and chemical formulas, and we wanted to search by the chemical structure and so on and so forth. And what this shows is that different data sources will have different needs and based on the domain and different types of search facilities. And increasingly, we will go beyond search. We are already going into natural language querying, wherein you can ask a question and you can get reasonably good answers. And then you need to understand the semantics of that particular domain. Some of that is encoded in the metadata. But in this case, we need to do formula and name search and so on. And you might think, oh, what's the problem? Well, the first time we searched, there is this ambiguity between chemical formulae and naturally occurring abbreviations. So if I search for OH, it brought me papers where people from the US state of Ohio, which is abbreviated as OH, was, because the paper had OH. But that OH is not OH. if you say, okay, and so essentially we had to disambiguate what is the chemical formula, what is a abbreviation, and we did that based on the context. And then for name, gold is an example. So you have gold MasterCard. When I'm doing a chemical search, I really don't need the gold MasterCard document with the gold MasterCard to be brought to be returned, because of course it's not talking about a chemical there in any real sense, and so on and so forth. So, and also after we extracted data from tables, which was reasonably doable in the sense that there is always some error in the extraction process that we weren't able to get 100% accuracy, but it was reasonable. And when I say reasonable, it's if it's from a digital document, we got about 90% or above accuracy. For really old scanned documents with lots of noises, then the accuracy goes down. So it's actually varies. We tried to do figure data extraction. That was successful to some extent, but not very well, because first of all, some of the figures were three-dimensional. So if you have a three-dimensional figure, doing the reverse engineering and extracting the data points is not feasible, because it's a lossy compression in a way. You go from 3 dimensions to 2 dimensions, and multiple points in the 2 dimensions map to the 3 dimensions. So we don't know what to do. But for pie charts and histograms and so on, we can extract the data much more easily. For lines and scatter plots, where you have lots of points in a small space, which are occluding each other, then it becomes harder. So we did a whole bunch of things. In the interest of time, how much time do I have?
35 minutes into your talk. So okay. 10 minutes more.
Okay, 10 minutes more, thank you. So that's what I thought. So I won't go into this. This is something that I already talked about a little bit before. So this is sort of where you could go in and you can say, okay, this is a formula, and search for the formula. And you can see that we used to have a general search, which is for text terms. You can do formula, and you can search for data sets. And with those particular terms as well as the formula. This is more of the techniques that go under tables here to extract table data. This is how it was working. So this is a simple search that we did with Flow, and it actually went, and you can say here table caption, and it just got you the tables. So in this case, it got you, in this case, we just did a simple word match, which was Flow. But if we had possibly put in Flow injection analysis, it would have got fewer search tools, and it would bring you a snippet of the table here, and you can scroll and see which table, and it shows you which paper it was from, title of the paper, authors, and the caption. And if you sort of click on this preview, you get that page from which this table was extracted out here. So you get a link between sort of the search results, and you can see a quick preview. And at the end of the day, this data which was extracted, you can see some experimental results here. This data that was extracted was put in a database. Now, then it becomes queryable and searchable and so on. So we did a whole bunch of papers there. Details are in the paper. And so we did some chemical name search, chemical formula search, structure search. Sorry, I'm going the other way. Apologies. Okay. And essentially what we used is, now talking about metadata standards and so on, what we used is we used a metadata standard called ORChem. ORE is so ORE is a standard, OAI ORE, and I'm blanking out, is a standard for metadata, and we use that. And what that does is it gives you sort of the document level information, author level information, venue information, table information, in this case, formula information for the chemical formula. And the idea is that, papers and data are not really different to us. it's all connected together. So you see these graphs where you have papers, this is the document, and there are these slides and the PDF and the web page and tables and figures in the paper, which chemical entities it's related to, and so on and so forth. I can't read this part myself, but everything is linked together. And in the metadata world, and then you can search and land, using, let's say, Neo4j or some sort of graph database. You can land somewhere. You can land at a table by doing table search. Look at the, go and get the data, download the Excel, and then go pursue the links and go to the paper and read about the thing if you want to. So that's sort of what our ontology did, and connected the data and the metadata together. So this is sort of named entity extraction, which we had to do. All of this was done automatically, and CiteCRX, the extraction of the document titles and the authors and so on are all done automatically. Right. So we tried to reuse existing standards as much as possible, and wherever there weren't, we added to the metadata terms to enable, in this case, chemistry. CirQL was a query language, and so on. SVG-ORE is a visualization of the ORE, and so that's this is XML based, and this is how it looked like. Okay, here's sort of the data model, and so on. So this was a highlight of somewhere. And we, by the way, the part that I haven't talked about is that we also had a real database where new data that people were doing simulation results and running experiments, you could submit your own data directly. And at that time, it would ask for the metadata, and that would be stored and linked to the new papers that are published. So because of copyright issues, we could not make the repository fully open, but it was partially open, and these were sort of, people were submitting data sets in these, the chemists use these Gaussian and CHARM-MM toolkit outputs. So tools were outputting chemical data, which was going through our workflow into the database. And then eventually people, when they were publishing the papers, they were linking it to it. And so this is, the new data was being linked that way. The old data was being extracted and put into the database. All right. I will, I have possibly 5 more minutes, so I won't go into the details of the other work. So once we have, the advantage of having the metadata as like a graph, a knowledge graph, if you will, is that we can build many different types of tools on top of it. So we built a collaborator recommendation engine, which would go in and find authors who have published things in the same field. Or sometimes you can say that you want a collaborator in this particular field, and it would suggest collaborators for you based on that. Just like Amazon or Flipkart goes and suggests, recommends you some item to buy, here you're suggesting collaborators. So I won't go into the details of that. And the other thing that we have worked on is citation recommendation. So you're writing a paper. Of course, senior researchers might know the field, but even then, there might be some papers you might not know of. So you could search using our digital library. You could get references that should be cited in your paper. We did a system call for expert search. So in this case, machine learning, and it would give you people who have worked on machine learning and where they are, and so on. So this is sort of this is showing one person and the areas that they have worked on, and so on. So I won't go into the technical details. The last item I will sort of mention is, if you want data sharing and we want this open repository with nice metadata, everybody linking to everyone, and with a good set of incentives, and there has to be trust. And so in May 2020, the work has been going on for a while, but there was a paper that was published on the so-called on the trust principles. And I think I have the reference for the original paper in the next slide. The trust principles are transparency, responsibility, user focus, sustainability, and technology. And so transparency is basically the repositories and data holdings can be verified by publicly accessible evidence, essentially preventing fake data, preventing nonsensical data, preventing somebody trying to malign somebody else's name by publishing some bad data and putting it in their name. Responsibility is, responsibility is that, but transparency is the principle by which you can sort of go and go and openly look at who is giving this and find the data. Responsibility is is to ensure the reliability and the persistence of the data, and gets into authenticity and integrity of the data. The data has not been tampered with. User focus. We put in all these data and then the users, nobody can use it or get it easily. So we need to have nice APIs. We need to have maybe some visualization if you're showing the data, and easy ways to extract data and share. Sustainability, this needs to be long-term. It's, unfortunately, our ChemXCR project was not sustainable. We got 5 years of funding. We could do that project as proof of concept. Well, at least Dow took it and did a tech transfer and used it internally, but the project, the web page right now is not there because of sort of lack of sustainable funds. So our next project, we need to think better on how we can make things more available. And to provide the infrastructure capabilities and the technology support that needs to be there. So we talked about FAIR principles, and so this was sort of the trust principles by the Core Trust Seal Board, the RDA, the Research Data Association, I think, met and they proposed these trust principles. I would suggest anyone who's interested in working in this area to look into that. And to give time for us to discuss in more details and engage in a dialogue, I'll sort of stop there. Briefly, I talked about data and metadata standards and interoperability, issues of fairness and trust. And then I showed you some of the AI-based tools that we have built, which primarily does information extraction and search. And I made a call that we, as a community, should actually line our incentives better if we want to make serious progress in this area. I'll stop there. Happy to take any questions and engage in, hopefully, some interesting discussions.
Yeah. Thank you, Prasenjit, for an excellent talk. The way Satya explained to you, we have identified discussants who have some questions for you. What I intend to do is that we'll have one round of questions from them and would see whether there are any questions from the audience, and then get back to the second round and manage the time. This is the way I want to do it. So before at the end, probably I share my excitement of listening to your talk. So now, may I now ask Nikesh Narayanan to pose his question. Nikesh, are you around?
Shall we ask other participants, all discussants also to put their videos on, please? Thank you.
Thanks, Dr. Saibaba. Am I audible?
Yes.
Okay.
Yeah.
Thanks, Dr. Prasenjit, for the insightful presentation. You have covered almost all the aspect of research data management and answered most of my questions. But I have one question in my mind. You mentioned about the linking between research data repositories and institutional repositories, that is digital libraries. So when we talk about research data management, the common questions comes in our mind is, why can't we use DSpace or ePrints as data repositories? We know that one of the limitation is handling the metadata, especially the domain-specific metadata. So my question is, do you know some systems that can handle both research repositories or digital library and data repositories, which can handle different kinds of metadata? Is Chemexir is that kind of product which can handle both finished product, I mean finished work like articles and the research data?
Yeah, I think DSpace is an excellent example, and there are, I think, increasingly publishers are offering sort of ways to load supplementary data along with the papers. So I think the other is, yeah, we can use DSpace and ePrints and so on, but the point is we have to bring the community together to all use one set of standards. And right now everybody's using different things. And that perhaps is more of a social issue than a technical issue.
Yeah, thank you, Prasenjit. May I now ask Dr. Usha Munshi for her question?
You need to unmute yourself, please.
Yeah, thank you very much. It was indeed very, highly provocative and excellent presentation where you have covered numerous contours of the data management and the digital libraries. My question is very generic in nature, because we know that data has been very influential of late, but hitherto it was largely unobserved in our scientific universe mapping process. Now, when we talk about the data for reusing and repurposing, it requires curation, sustainability, and access to data. And where this data access depends on knowledge infrastructure. What my question is that there's nothing like one size fits all kind of a thing. Different organizations are using different kinds of techniques to curate their research data in their respective fields. But we also know that research management, data management is integrated into research workflow, as you also mentioned in many different ways. But in order to move from a diffuse and unsystematic practice to a structural and organizational wide execution, you need a good basis. So my question is, what could be that good basis for evolving a sustainable and efficient mechanism of a data repository for reuse and repurposing?
Yeah, so that's essentially solving the world's problems. And that's a huge task. But I think as you mentioned, so there are these, in the chemistry world, there are these e-notebooks that are being created. And Microsoft Word came up with a chemistry version where you can annotate chemical formula, chemical names, and so on and so forth. So the data creation tools are becoming more and more metadata aware. But universal sort of reuse, exchange, and solving the heterogeneity problem, I don't see an immediate immediate solution. But maybe I should ask a quick follow-up back. What do you mean by a good basis?
Where do we start? Say problem, many kind of users or providers of these services, data services, they talk about the data policy, and also they talk about the holistic approach to this data. but they in the process, I feel that we need to gradually step up. You take one by one step. But what is happening is when we are holistically trying to kind of address these issues, we get stuck up. Neither we are able to provide the data services, nor we are actually, looking at various parameters. You also talked about, the indicators. We really don't know where to start.
Right. So I think part of this might come from some standardization efforts from some sort of big players in the community. And in the US, people started publishing their data once the National Institutes of Health said that any data that is produced from research has to be published openly online. And the National Science Foundation started requiring a data management plan. So now we have gone sort of over that. And on the other side, maybe if some of the big players, like I hate to have, put the power in the hands of the corporations, but if Google comes and says that these are the formats that we will link and enable search and so on, then perhaps people will be more incentivized to put that information in those types of formats and so on. So it has to be multi-pronged, but essentially, or if the society, so if the Astronomical Society comes in and says that we are going to do this and all our papers and so on, we will have this, this is what we will use, then I think some of the heterogeneity will be gone. But at the end of the day, I think some of the holistic means is actually to some extent useful. So, as much as we can do with metadata, sometimes as much as we, I read a paper and I understand the algorithm exactly, but if I have to know why or how they are doing this type of parameter tuning, I have to pretty much email the authors or call them up and say, hey, well, what really do you mean? So in some sense, at some point, the automated infrastructure breaks and we need to go in and look at the entire picture. But a lot can be done by mandates and standards.
Yeah, thank you, Usha, for raising interesting question. And now, can we move now to Dr. Bharati?
Yeah. Good evening, one and all. It was quite a very interesting talk. After listening to you by the factors on FAIR and trust principles, I have a very simple and generic question. The mechanism used to authenticate the research data in the repository. I want your views to be elaborated on the mechanism used to authenticate the research data in the repository.
Right. So I think that has to be based on, that's where the librarians as the gatekeepers sort of come in, as in we need curators and moderators who would at least do some checks on what the data is, what the quality of the data is. And, just like if the book has been put in the wrong shelf, of someone working in the library walks to it and then they say, oh, this is in the wrong place, they move it in the right place. So some of that has to be done with the curation services. And like in CiteSeer and in some of the other data repositories that we had, when people submitted data, it wouldn't automatically go out. It would be moderated. And we were doing a minimal check to see that this doesn't look like total garbage. And if it was, there's lots of spam data that comes in, people just do it for fun or whatever, and then we would throw it out. And only something that looked like chemical data or experiment data we would allow. But we were not chemists, so we perhaps might have allowed some data which would have been fake or something. So at some level, we would have this curation. Number two is the data has to be linked with the creator, and we can create a authentication mechanism by which if somebody puts in some data and says, oh, I have put in the data, especially if we use the identifiers like ORCID or something, then there would be an automated email to me saying, hey, somebody has posted the data, is it you? And I can say no, and then that data will be deleted. A lot of the curation right now has to be done maybe manually, but we can build better and better AI tools which would do automatic classification. So it could automatically check and say, no, this looks like garbage data and this looks like real data, just like spam detection. And then someone can go in and check quickly and curate it. So these are some of the solutions that the field is currently using.
Yeah. Thank you. Thank
Dr.
you, sir.
Saibaba, actually, I have a clarification and I want to comment on what Dr. Bharati Ramaya said about authentication. Because when we are collecting the data, we are collecting the data from the public sources like thesis. Okay, we are not just collecting the random data. We are collecting the data which is already there in the thesis or in the publication. So the question of authentication doesn't appear here. That is what is my comment about. Because already the data is available. Data is either in the thesis or in the research paper or anything. So the question, this is authentic data. There is no further authentication for this particular data. That is what I say.
Thank you, Dr. Ashok Asundi, for stepping in and adding clarification. So I think still there may be issues in terms of, every thesis would not be similar, and these are the issues could come. I think there are challenges be there. Yeah, thank you. And now I invite Rajat. In fact, Rajat, so far we've been listening from the faculty from the information science department. Now a student will ask. Rajat.
Yeah, Professor Saibaba, thank you. Professor Mitra, it was wonderful listening to you. My question is more or less on the same lines of Madam Usha's question. Today, you see, there's a lot of discussion going on with respect to research data, how to manage it, and the infrastructure around it. Essentially, because data is becoming more available, and there seems to be a lot of excitement around it. But through this process, what one is not concentrating on is what I feel, how to bring researchers together for this to happen. I know you mentioned about incentives, fair principles, and interestingly, also there are a lot of tools like papers with codes, colleagues, and others. But seemingly or unseemingly today, it's not the same excitement trend shared by researchers or efforts being made to organize research data. So I wanted to know from you, what do you think should be the strategies that universities should follow, and what best practices can be included so that researchers are actively part of research data management ecosystem?
Yeah, I think, so I mentioned some of those things in my talk, but one thing comes to mind is, and in our conversation, I think yesterday you mentioned about the data briefs that are being published. And so essentially now what we are saying is publishing data itself, just by itself, is something worthy of credit, a good quality data. And some of the community has gone into creating benchmarks as something worthy of doing. So the Trek community in the information search space has been creating benchmarks for quite a time. And there's a conference called LREC, Language Resources, where people publish benchmarks. So just like publishing benchmarks, we can have places where people will publish data sets and then say, these are all the open research problems that can be worked with these data sets, and then the community can go in and work. So one of those is the data briefs that you had mentioned, and one or two similar things. Now, the other thing that has been done, I think slowly towards in our community, is the conferences are having tracks where you mentioned papers with code, so the tracks where we say that these results are reproducible. So essentially, when you submit the paper, you submit the code and the data, and anyone can come in and check the results. And in our case, we have code, and where there is no code, you can just publish the data, and then people can check that whatever correlations, analysis that you're doing, regression, whatever you're doing, can be verified on this particular data. And the idea is that we have a different track of papers, which is reproducible track. And the idea is that reproducible track papers will get more recognition. So if I publish in a reproducible track paper versus a non-reproducible paper, the community should give more recognition to where things are reproducible. In psychology, they redid the experiments on like 100 of their most influential results, and they saw that only 33% of them were reproducible. So so by getting to openly publishing data, we can know which papers have published their data and which have not. And in some cases, it puts a disadvantage to companies because some of them cannot publish the data because of confidentiality reasons, and we can understand that. But if you say that you did some research where you're observing stars in the sky and you cannot publish that because of confidentiality reasons, that doesn't cut muster. So that's sort of my answer. I'll stop there.
Yeah, thank you. Now let's listen to Dr. Sangeeta. She's she's representing health sciences. I think Dr. Sangeeta.
Yeah, thank you, Professor Saibaba sir. Good morning, Professor Mitra. Thank you for your very enlightening talk. I wish to know what should be the skill set for the librarians, especially for the medical librarians in India, so that they perform efficiently in this digital data intensive era.
Yeah, I think the role of the, sorry?
I have one more question. And where can we collaborate? Is there a common area of interest for both us and researchers?
Yeah, I'll take the maybe second one first. So where can we collaborate? I think we need, I think the library community understands the issues with data and archival and how the data should be presented and the metadata and so on. So one role for the librarians would be as gatekeepers. When somebody submits data to a repository, the librarian could, if it were up to me, at least I could say that they could give sort of a warning saying that, hey, if you publish the data in this way, nobody will be able to use it. Fix these things, these formatting issues, these, put in more metadata. Don't use this format, but use the other format because this is more archival quality. And it will, this other format is going to be deprecated in 2 years, whereas this will last 20 years. So that type of domain knowledge, the scientist is going into the lab and pouring chemicals and getting some data. All they want to do is put it out. They don't want to know about metadata and things like that. So that's where the librarian can come in. Again, the gatekeepers about the quality of the data and so on, especially you mentioned medical libraries. We did some work on automatically generating Wikipedia articles. So that's, I have some work on that. And we were very careful about going into the medical domain. And we said, only information that we get from papers will be published, will be used to create our articles, because we only want vetted information. So we created an article and then we put it on, we also did not want to publish it directly. We put it on a list where some expert would come in and check it. So they came in and checked our article and they said, no, this is bad information, rejected. And then we came in and we said, why? Because we took this from this journal. Here is the reference. They said, no, it's a C-grade journal. That place publishes everything, and it's not well vetted. So the librarians, I think, especially in the medical case, I'm asking everything from our librarians. That is, I want them to know the medical sciences, to say this is good information, this is bad information. I want them to know about the library science and issues related to standards related to data and metadata and technical standards and so on. And so working together, I think scientists and librarians can create better quality data and products where data and papers are linked together. So I hope I have answered that question to some extent.
Yeah, thank you, Prasenjit. I think now I move to Dr. Rajkumar Bharadwaj. Dr. Rajkumar?
Yeah, thank you, Professor Saibaba, and thank you, Professor Mitra, for this wonderful talk and addressing all the issues meticulously. I really enjoyed your talk. Thank you. And I have a very simple question actually. Since in India, as a LIS professional, I don't see that there's any technological problem in managing the research data. But the problem is there is no policy in place. There is no funder policy to manage the data or managing, preparing the research data plan along with the proposal. And there is no national policy as such. Where means those professionals who want to start the data repositories and they would like to populate their repositories. So from which point they should start? Like what should be the strategy? Is there any best practices? Like there's a practices of Harvard data repositories, because there was no policy there in Harvard, but still they have a successful data repositories. So if you have any best practices in mind where there's no policy in place, and if we can populate our data repository, this is my first question. And the second question is that how to deal with the personal and sensitive data, because we don't have a GDPR here, and the LIS professional don't know how to deal with the sensitive data. So these are some two questions in my mind, if you can address these.
Yeah, so I think if we are, I would say the first question, my advice would be to have a multi-pronged solution. So one would be to look at the most successful data repositories in the world and do something similar and in the Indian science space. But also along with that, it's not just a technological solution. First, we have to find what technical tools are more usable and what people are using in the community and so on. But then we have to go to the communities and get buy-in from the communities. So if you do that, then we would have to go and talk to the Indian Statistical Society and the Indian Computing Societies and the Indian Medical Societies and try to get buy-in from them and say, hey, and that's also a good exercise in vetting the infrastructure. We say, hey, this is what we are building. We want your researchers to come in. Will you work with us to make something that works for you? And they might come in and say, no, this does not have these features. We need to do that. So then we go back to the drawing board and then we try to get those features in. And gradually we, like in our case, we got the archaeologists saying they want something else, the chemists saying they want something else. So actually then we did the common part, we abstracted out and we now call it Seer Suite. And then we have some verticals, which is for each of these different things. And then together, we have, I think, a robust infrastructure. And the second part of that is that we need to have policies. So while you're talking to them to use these things, we can talk to these bodies to say, can we create some policies and standards that we can then have the entire community adopt? Maybe the National Digital Library Initiative can come in and create some of these sorts of standards or repositories and support in these efforts. So if you bring all these people together and then you take the technological solutions that have worked and then improve upon them, I think that's the way to go.
Yeah, thank you very much.
Yeah, so now shall we move to Dr. Lata Suresh?
Yeah, thank you so much, sir. And first of all, let me congratulate Dr. Mitra for such a nice presentation. While answering one of the question of one of these discussants, you have mentioned that NIH has recommended that whatever data has been collected should be made available in public domain. I would like to mention a book by Vijay Kelkar and Ajay Shah. They are former bureaucrat in Indian government, and one of them was an economist. So in their book, In Service to the Public, Republic, have recommended that government need to release much more information in the public domain, particularly the micro data. Whatever information can be obtained through the RTI Act should be published. The data gathered using public money must be released in the public domain. So my question is, what is the key to ensuring a company or organization the compliant with all the laws and regulation pertaining to this research data?
Yeah, that goes a little bit beyond my expertise, but I think the key is, first of all, we have to have the, we not only have the policies, but first the government should be doing it itself. So all the governmental agencies should be publishing this data and trying to make the data available. And then, of course, I think sometimes enforcement is an issue because of lack of clarity. So we need to, the government can entrust some working groups or committees can come up with, a 2-page set of instructions that if you are working in this field, this is the data that should be published. Now, if we are talking in at least in the US, to the extent I know, this is only about data coming out from publicly funded works. So if it's from private funding, they don't have any obligation to publish the data. They can keep it secret because of corporate confidentiality reasons. So the key is that, okay, first we tell them clearly, this is what you need to do so that it's easy to follow and step by step. And then after that, it has to be carrots and sticks. You can sort of create rewards saying that if you meet these standards, then you get the next installment of money. So you put those things in the contracts. And at the end, if for future contracts, you can look at, whether these companies have been publishing the data or they have not done a good job. And based on that, you make that as part of the evaluation criteria. These are some thoughts that I have, but once again, I'm not a social scientist or policy expert, so I'll defer to them for the final word.
Yeah, thank you, Prasenjit. I think we have now completed first round of discussion from the discussants. I think we are now already 8:53. I think I would like to see if any of the audience participants have any questions. I would request
myself, Dr. Asundi, I want to.
Yes, sir. Yeah, please.
In 2017, I visited United States and I had a first-hand information on research data management. And in fact, in one of the universities, Auburn University, I actually had an interaction with the associate dean in the library, who actually looking after the research data management. And one thing is that about the policy, there are about 51 universities in the United States where the research data management is being practiced. And out of 51 universities, then 68% of the universities have research data retention policy. That is very important, data retention policy. And in fact, the Association of Research Libraries actually has come out with about 4 kits, spec kits, spec 334 Association of Research Libraries has already published some kind of publications on research data management. And in fact, it provides about 28 areas in which somebody asked what are the skill sets required for the librarians to the research data management. They actually identified about 28 topics
Dr. Asundi, you have a question to Prasenjit, or are you making
I just want to add something.
You want to add something? Maybe I think
there are some questions raised.
Yeah.
Dr.
I
Anand
think
has raised his hand. So if you could.
Yeah. So I think thank you, Dr. Asundi. I think we will give an opportunity for questions to utilize Dr. Prasenjit's presence. I think no. Dr. Devendra, can you facilitate some of the questions? I'm able to see the questions.
Actually, Dr. Anand has raised his hand.
Okay, let Dr. Anand, please, Dr. Anand.
Dr. Anand, you can ask the question, please.
Yeah, Dr. Anand is the.
Okay. There is one question.
Yeah. Dr. Anand is now saying in. No,
Okay.
wait. Devendra, please wait. Dr. Anand?
Yeah.
Yes.
So I have two straight questions. So one is, we talked about metadata and harvesting, retrieval, and all of that. And data is becoming as important as the journal publications now. And there is a more focus, in fact, on that. So I would like to ask the speaker, is there any effort anywhere, either a project or some effort to do data tagging or a data classification, something similar to DOI we evolved for digital articles? Otherwise, as of now, we are using data, metadata standards and all, which are developed for something else for the data. So my question is there any specific effort in terms of tagging, classification and all, which will eventually help all of us to really manage it better?
Yeah, I think that's a great question. And yes, there are certain efforts in data data tagging, and this is it's actually sort of been we see as in the Wikipedia revolution, so to say, the citizen science efforts have been very very influential. And so there are actually companies which have built products that allow you to do data tagging and using it for data classification. I think SAS, which is SAS, had some functionality. There were, I think, DSA. A company used data tagging, and so it's used maybe not as widely as possible, and not with standards. If you look at sort of the social web, there is a lot of that being done. There used to be this social benchmarking site called Delicious, and Flickr had that, and Picasa had that, and so on and so forth. Maybe a lot of it was for photo tagging, but sort of the same technology can be used for data tagging.
Yeah, I have a second quick question, if I can ask. You stressed a lot on incentivization to get better data sets and also to more research data to manage. And you also used in the beginning examples of Springer Nature platform for research data management and all.
Right.
Incentivization per se, it never worked in the publishing industry. Publishers will take money from authors, and they don't incentivize the reviewers. And now, if you look at publishers getting into research data management platforms, do you think incentivization will really work in this field, or will it also become any other journal publishing medium, like no incentivization but keep doing, let publishers make money? What's your thought on that?
Yeah, no, so I want to clarify that part. So in no way am I endorsing the Springer service. I was using that because they have made the point very clear, and I wanted to use some of their material. It is a problem because Springer, as you said, is a paid service. So if you have to host their data there, you have to pay, and you have to keep on paying in order to keep that data hosted. We do not, it's getting into the issues which are related to publications too. And in a sense, we, the research community, are generating the data. We have the intellectual capacity that we are putting in, and we should not get into the publishing and depend on the publishing industry to really host our research data infrastructure. I think the associations, like in our case, the ACM or the other associations should set up these research data sharing infrastructure. So just like, you know, in our community, archive, medRxiv, bioRxiv, these have now become places where people are putting their papers online. And then there were whole journals who came out from these, I think either Springer or maybe Elsevier, and said that we are going to take the journal to an open publishing model. And so I think my preference would be to support data infrastructures which are not tied to publishers.
Yeah, thank you.
Mahesh,
we are already at 9 o'clock now.
Shall we take a last question of Dr.
We'll
Mahesh?
have one last question, Dr. Mahesh. Yes, please. Dr. Mahesh.
Thank you, Dr. Saibaba. Well, interesting presentation. That the one question that I had, I think you already answered, which was exactly what Dr. Anand Bhairappa was asking. You know, maybe 10 years now. I was looking at your first two slides, of course, which was just illustrative, an introduction slide. Whether, you know, 10 years from now or even in a lesser period, whether the Elseviers and Springer Natures would be paywalling research data, even if the same data lay scattered as open data on the internet. So that was a thought that came to me as well. And maybe I would, you know, at some point later, Dr. Satyanarayana can also touch on this if there is time. But then the other question to you was, you know, I was very excited to hear about this table sphere that you spoke about and the immense possibilities that that can open up, integrating that into something like Google Scholar or even in a standalone mode, possibility of identifying papers that have more tables or ranking, you know, papers by tables. But what I wanted to know was, like, say, maybe it is a wrong comparison, but, you know, kind of comparing it with Google Scholar, where, you know, a Google Scholar indexes the metadata that is exposed. But then these tables being integral part of research papers are not many times exposed because they are, you know, so how do you take care of this? Is it only applicable to those open data, or is there some way that you're addressing this? Thank you.
So in our tool, we are extracting the data from PDF. There are other people who have extracted the data from scanned papers. So older papers are not in digital format in PDF, so they were scanned. So there, essentially, we were identifying, oh, this looks like a table. And the technique there was to look for sparse lines and some columns and rows format. And then we say, this is the table. We find the table boundary and we sort of do the reverse engineering and extraction. In some of the digital formats, maybe going forward, we possibly will have clear metadata, you know, begin table, end table, and then we can extract it more easily. But right now we were just extracting it using the layout information. The Google Scholar has not done it. They are a very small team, and there's no money to be made that much for this functionality. So I don't want to speak for them, but I don't think they will implement this in their functionality. But there is a site called Semantic Scholar, which has worked after us, and they have the latest, greatest tools with respect to table extraction. After our project finished, their project has sort of taken up the baton, and Semantic Scholar does table extraction, and you can go in there and for whatever papers they're indexing, you will find the tables and search and get the data and things like that.
Yeah, thank you. I think it's time now. We have to wind up. It's already 9:05. I don't want to spoil the excellent discussions we had so far. I think you all agree with me, and it's my privilege now to just share my impressions. I was really excited listening to Prasenjit. I think it's, for me, those of the participants who are the students of information science, I think you can see a gold mine of problems which we can address to it. I think we all have to migrate from doing many routine things in information science to linking to data science. I think you rightly pointed out about the importance of sharing the data. I think, many times we have this temptation of repeating things which others have done. Somebody does something and repeat it. I think sharing data is very important to avoid duplication of efforts. We have a lot to be done. That lot can be done, and why we should repeat it. I think so. Of course, there are issues. Of course, you rightly coined fair, and we have to have fair. You have to be fair to people who are doing research. We have to be fair to the people hosting the research. And also the trust is important. I think it's very nice coin words which you have said. These are the challenges. I think the way we look at it is that whatever we do it, we're going to live in a hybrid environment. There's a data there, research is there for long years, a lot of papers were there. Now you are finding out methods of extracting it. But while you do it, it will be quite some time, since the data will continue to be added in that format. I think it will take some time. I think I can't foresee a situation where everybody adhering to a particular thing. See, simply references are not in the same format. You can see the challenges which we have. I think that's the challenge which we have to address. In fact, normally what would happen is that whenever you propose a new method, there would be some doubts about the question, how it will be maintained, how it can be done, what about privacy, all sorts of questions will come. I think the best thing is to start doing it, and then it will happen. And then we sort it out when it happens. So thank you, Prasenjit, for an excellent lecture, your thoughts sharing with us. And also you demonstrated how it can be done on very diverse areas, be it chemistry, astronomy, or whatnot. I think it looks like you have demonstrated, and I think you should show the way for the researchers, aspiring researchers in this domain. And thank you, a big thank you from all of us for your excellent lecture. I also want to thank the discussant. I think Dr. Nikesh Narayanan is from Dubai, is coming all the way, present there. And Dr. Usha Munshi from the India International Center, New Delhi. Rajkumar Bharadwaj from the Central University, Punjab. And Dr. Sangeeta Narang from AIMS. And Dr. Bharti Ramaya from the Mysore SJCE, and Lata Suresh. She's actually Indian Institute of Corporate Affairs. I think the corporate issues which has to be addressed. And of course, we have a student who was working in information science and moved to become a student, Rajat Srinivas. I also particularly thank Dr. Ashok Asundi for adding and getting clearances, and Dr. Mahesh, Dr. Anand. I'm very sure, unfortunately, it is a virtual platform. Normally what would happen is you have a talk, then you have a break, and during the tea times and the lunch time, you have opportunity of interacting. Unfortunately, COVID has taken away that opportunity. But I'm very sure that the excitement and the doubts which are put forward by the many other people, I think we probably can plan a session of discussion at a later time. And this is a request to Satya to facilitate such thing. After this conclave, our LTC2021 is completed. Based on these interactions, I think we should have something which can be done. So I think it's been a privilege and pleasure listening to you and also coordinating this. And thanks, Satya, for giving me this opportunity. Now, I think we would now move to the last item before it becomes too late. May I now ask Professor Shalini to conclude. Of course, maybe Satya would have his last word. Yeah, Professor Shalini.
Thank you, Professor Saibaba. Even under normal circumstances, vote of thanks, according to me, is inevitable but avoidable item on the agenda. But today, especially at this hour, when I'm standing between dinner and the whole program, which is extended to more than 2 hours, I would be actually, I will be cursed, but still, I cannot run away from the task that has been assigned to me. So I would go ahead and still do the formal vote of thanks for the whole event. Let me just start with what I have been thinking about saying, you know, particularly given the fact that because of the COVID, we had to redefine the whole format, redefine the, I mean, not just redefine, reimagine the whole conclave LTC 2020, which became 2021. So in a way, I would say it would be an understatement to say that we have seen a watershed moment, not just in the world, but also in sciences. Because something that COVID has taught us, as historian Harari says, you know, that a crisis can give rise to something new, something good, something bad as well. As an optimist, I would say it is something good, especially in the context of the theme of the conference, that is e-science and digital libraries. Because I might venture to say, in the context of all this that is happening in the last 8 months or 1 year almost, let us say, I would venture to say e-science has become open science. Data has become open data. Especially if you look at the one episode of one article by, unfortunately I would say, an Indian, Mahendra Mehra, whose article in Lancet about the adverse effect of HCQ had to be retracted. What was the main reason? It was about the data that they could not actually share, or they could not expose the data, especially the Surgisphere data set that they use. So what I'm trying to say here is, let us look at this COVID pandemic, etc., as that redefining moment for e-science, data, etc., wherein we are probably moving towards open data sharing becoming a, I would say, requisite for any science or any research. In fact, if you look at Lancet, Wellcome Trust, WHO, and all these organizations, they have now made it mandatory about some of the issues that you discussed about data, that the data has to be, they have, put in place certain, I would say, certain checks and balances to ensure that the scientific data that supports the article is as authentic as possible, given the various challenges that we face. So given this, I look at it as something that we all should look forward to in one sense, because always crises give rise to something very good as well. Just like wars give rise to something, good technologies and good policies. In the context of the theme of the conference, I would say we are moving towards that, as I said earlier, science becoming actually open science, data becoming open data. And most of the, I would say, organizations or stakeholders, whether they are journal publishers or funding agencies, they're moving towards this. So particularly if you look at some of the projects that have been undertaken, the COVID portal, data portal by the European Commission, which is funded by so many organizations, that's an excellent example of the way in which probably open data will move forward when it comes to not just the COVID data, but all scientific data. So with this, I would now like to move on to the actual vote of thanks, which has already been done by Professor Saibaba. I would like to thank particularly, very specially, Professor Prasenjit Mitra, who not only agreed to speak on this date, on this topic, especially I would say, because I did not give him a choice regarding the topic. I said, Prasenjit, you have to speak on this topic, that is digital library and research data management, without flinching. And he said, yes, I will speak. So thank you so much, because usually, speakers negotiate on the title of the topic and all of those things. Thank you so much. And despite the fact that, you are in the, I know, the holiday season, that is Thanksgiving season. So yesterday, Thanksgiving, you were here for the rehearsal, and today you are here. Thank you so much for being with us and for readily engaging. Not only that, enlightening. You really gave us an intellectual feast as far as the topic of digital libraries and research data management is concerned. I hope the intellectual feast will somehow manage the, the hunger that most of the audiences and speakers and panelists, etc., are probably feeling, because we have now crossed 9 p.m. Now, my next, I would say, I would be failing in my duty if I don't thank, even though Dr. Saibaba has already done, our 7 panelists who readily agreed to be part of this because it's always, the questions are very important to generate this engaged discussions, as I have been saying. So we have been fortunate to get all, I'm not going to name them again because it will take some time. So all my friends here who are able to join us and ask questions and actually give us this outcome of engaged discussions. And I would like to thank, of course, our organizing partners, Informatics India, represented by Satyanarayana, and of course the that is Rajiv Gandhi University of Health Sciences. And I think we have lost our Vice Chancellor, who was the earlier speaker here. And then the other partner, which is represented by Dr. Saibaba, that is NIAS, National Institute of Advanced Sciences. And then another partner is the CSIR Fourth Paradigm Institute, represented by Dr. Mutkavi. So I'm sorry you could not get a chance to ask your question. I'm sure you will be able to get a opportunity some other time, or you can write a question to Professor Prasenjit. And I would also be failing in my duty if I don't thank the audiences. They're still, I think we have lost a couple of them, but we still have somewhere around 200 audiences in this. So thank you so much, all of you, for being part of this, and then being not just a part of this conference, but I am sure we all serve us with our goal of actually building a community for collaboration. Hopefully it will lead us to collaboration, because that is one challenge that the COVID has thrown us, is that we can only move forward with collaboration. So thank you one and all for being with us, and over to your dinners, I think I would say. Unless you've already finished your dinner.
Whether Satya would have the last word, or Dr. Shalini's last word.
I think the chair always has the last word in any event, and followed by word of thanks. All that I will say is all of you, good night and enjoy your dinner. And please remember, on 11th we have the 17th annual lecture. You will all get the invitation. Thank you all.